I know they're in the lab. We use them all the time. They're just not here.
Get confused.
Where's the off button?
Hey, Alfredo.
Yeah.
What do you call a duck that really likes fireworks?
What?
A firecracker.
To start the acids and bases lab, we will need to first grab and calibrate a pH meter. To do this, we will need a pH 7 buffer and a pH 4 buffer. Remove the electrode and place it in the pH 7 buffer and calibrate it to 7, and then place it in the pH 4 buffer and calibrate it to 4. Make sure to wash between buffers. For exercise 1, we will be observing the pH of some common solutions such as orange juice and apple juice. Notice that the pH of orange juice and apple juice are slightly acidic. Make sure to record data in an organized table. At this point, we started exercise 3, comparing the pH behavior of water to a buffer, as it was a shorter exercise than exercise 2, to be completed later. Here, we mix 30 milliliters of the 0.2 molar stock solution of sodium hydroxide with 60 milliliters of the 0.2 molar stock solution of HAC. We measured the pH of the water, and then we added 10 milliliters of 0.2 molar HCl to the tap water. And then we recorded the new pH of that solution. From our observations, we found that when we added HCl to the water, the pH got lower, thus making it more acidic. I have no idea. In this lab, we observed that protons fully dissociate in strong acids and only partially dissociate in weak acids. Knowing this, we find that a strong acid dissociates completely in water and cannot react in the reverse direction.
Yeah.
While a weak acid partially dissociates and can therefore go in the reverse direction, establishing an equilibrium.
Are you serious? This isn't hard.
When we added the buffer to the solution, however, the pH was slow to change.
Okay, cool.
These results make sense, as a buffer solution is an aqueous solution consisting of a mixture of a weak acid and its conjugate base. Therefore, the pH changes very little when a small amount of strong acid or base is placed into it. At this point, you can begin exercise 2, observing the pH behavior of strong and weak acids. For this exercise, you will need to prepare a series of solutions from the HCl and HAC stock. You need to prepare at least 4 solutions ranging from 0.2 to 10 to the negative 5 molarity. To do this, you will need a graduated pipette and a 25 milliliter volumetric flask. You will then measure and record the pH of all of these solutions and then prepare a graph of pH versus concentration.
Alright.
We noticed that as the concentration of HCl went up, the pH lowered, thus making the concentration of the solution overall more acidic.
What is this?
Dilution number 4.
Make sure to wash all glassware and dispose of buffers and solutions appropriately.
Yeah, make sure you get
Make
as
sure to
many
put
knots
the
as you
electrode
can.
back in its container and wrap the wire for its next use.
After cleaning beakers, place them in the appropriate place.
Where does it go? Now, congratulate your group members for making it through this week's lab.